solving the traffic congestion at the UN Avenue Plaridel Street intersection. This intersection and its vicinity has increasingly become heavily congested. This video presentation aims to provide information on some ways to reduce traffic in the area. Hopefully, this video will be a catalyst for traffic experts, engineers, political leaders, government agencies, and other stakeholders to pool their efforts to implement whatever will be the best solution to solve the traffic congestion in the area. There are currently two proposed alternatives to solve the traffic congestion at this intersection, namely, number 1, a tri-level flyover proposed by the Department of Public Works and Highways or DPWH. Number 2, a channelized flared intersection based on studies conducted by Mega Cebu and the University of San Carlos. Channelization entails the building of islands in the intersection for efficiency, added safety, and for providing a refuge for pedestrians when crossing. The original design of DPWH is a 4-level flyover as shown. It has now been reduced to a tri-level flyover by cancelling or deferring Level 4. Level 1 is ground. Level 2 is underpass. Level 3 is a left-turning flyover. The alternate design is a channelized flared intersection. The flyover complex will cost 2 billion, while the channelized flared intersection will cost only 55 million. There will be a savings of 1.9 billion, which can be used to develop more traffic solutions on a much wider scale within the vicinity of the intersection. The breakdown of the cost of the 2 billion tri-level flyover consists of underpass at 1 billion, left-turning flyover at 0.5 billion, improvements to replace Level 4 at 0.5 billion. The present DPWH tri-level flyover plan as shown has no Level 4. Level 4 was cancelled or deferred as shown in the previous slide. The Mandawi to Consolacion portion of the intersection has no improvement yet as of this plan. If Level 4 is restored or another type of improvement is made, the cost could be at least 0.5 billion. The flyover is supposed to result in a smooth flow of traffic in 4 directions at this intersection, but this will not be the case. There is a traffic light at the Pacific Mall intersection 900 meters away, and another traffic light at the Cortez Plaridel intersection 1,200 meters away. Traffic may improve in these 2 directions only if similar expensive flyovers are built at these 2 intersections. This simulation will show that vehicles will easily and quickly get stuck at these intersections, which are presently choke points. What can be achieved by the flyover can be practically achieved by a flared intersection at 5% of the cost of the flyover. Improving traffic at one intersection in only 2 directions is not worth the expense of 2 billion. Project studies by the University of San Carlos were made to solve the traffic congestion in the vicinity of the UN Plaridel intersection. 2 studies have been made on the UN Plaridel intersection. To further reduce traffic in the vicinity, USC also did a project study on the AC Cortez Plaridel intersection. These studies of USC graduating civil engineering students were supervised by engineer Lynn Madrona. She has a master's degree in transportation engineering from the Asian Institute of Technology. She is currently a professor and a reputable traffic consultant of the Cebu City Transportation Office and Mega Cebu. The Mega Cebu Subcommittee on Infrastructure did additional studies to complement the USC studies. All studies made by USC and the Mega Cebu Subcommittee were done at no cost to the government. These are the sample contents of the studies. Design process. Design of signalization. Massive traffic counts. Analysis of traffic volumes. Equations used and sample calculations. Comparative analysis. Determination of the best alternative. The channelized flared intersections were chosen because they are as effective as a flyover and are very cheap to build. This slide will show what a budget of 2 billion can do to solve the traffic congestion at the UN Plaridel Intersection. One tri-level flyover versus 17 ground improvements consisting of 9 flared intersections with traffic lights, additional 4-lane Butuanon Bridge, 20 pocket lanes, a 5.4-kilometer bypass road with bike lanes, wide sidewalks, and massive landscaping. This slide will show the top view features of the tri-level flyover and the 17 ground improvements. The influence area of the flyover is only here. The influence area of the ground improvements is much bigger. The 9 ground intersections are shown in green circles. The additional bridge is here. The road widening is shown in this blue line. A shortcut option is shown in this dotted blue line. It will have lower construction cost but higher road cost. The road opening portion is shown in this pink dotted line. 50% of this road length for a 4-lane road has already been donated by the lot owners to the city of Mandawi 15 years ago. This road alignment is mostly a barren area with very minimal road problems. This makes the completion of this road opening much cheaper. This is a typical layout of a flared intersection. From a 4-lane road, it flares into at least 6 lanes. This is a close-up view of the intersection. All travel directions will be made available for movement. There is no need for some restrictive signs like these at the UN Plaridel intersection. These kind of restrictions are increasingly becoming common in Cebu, worsening traffic in some areas. Tricycle and jeepney rides will be reduced because of the convenience of biking and walking options. This table shows the cost details of the 17 ground improvements. Payment cost of acquiring the land right of way. Payment cost of the buildings that will be hit. The construction cost. The total cost of the ground improvements. The tiny numbers on the left of these columns are the rough calculations on the land row cost and construction cost. This table summarizes the benefits and cost comparison of the flyover versus the 17 ground improvements. The breakdown of the cost of the ground improvements is as follows. Land row is 790 million. Building row is 682 million. Construction cost is only 528 million. The total of the ground improvements is 2 billion, which is equal to that of the flyover. Let us estimate the benefits of each alternative. The numerical calculations of the benefits can be done in a later study. While this data is not yet available, numerical estimates will be made here to be able to explain the procedure of the benefit cost analysis. For the ground improvements we have savings from lesser fuel and operational cost, savings from lesser health cost due to lesser pollution, savings in time and production output as time saved is money earned, money derived from increased investments due to better infrastructure, increased taxes from increased realty values and increased employment, other multiplier beneficial effects. For the flyover, we have a high side estimate equivalent to 20% of the above. All these benefits can be monetized into pesos. For the ground improvements, the benefits are estimated to be 20 billion over an assumed 20-year period. For the flyover, it is estimated to be 4 billion. Now let us estimate the benefit cost ratio of each alternative. The benefit cost ratio for the ground improvements is simply B divided by C equals 10. Similarly, the benefit cost ratio for the flyover equals 2. Comparing the benefit-cost ratio for both, the ground improvements alternative is 5 times better than the flyover. Let us look at the comparison of the raw cost and construction cost of the two alternatives. For the 17 ground improvements, the raw cost of 1.5 billion is 3 times greater than the construction cost of 0.5 billion. For the flyover, it is radically the opposite. The construction cost of 1.9 billion is 19 times greater than the raw cost of only 0.1 billion. The enormous raw cost of the ground improvements at 1.5 billion is not a big problem. The cost to the government is like an investment. The government can recover the investment in just a few years based on the enormous benefits mentioned previously and above. This slide will show examples of alternate routes that will be provided by the 17 ground improvements. For example, you want to travel from point A to point B here. You have to go through the existing and congested road marked in thick yellow line. If there is an alternate road, you will try to avoid the congested road and use the alternate road instead. Another example is from point C to point D. The result is the same. This slide will demonstrate the massive transfer of traffic from congested roads in the vicinity of the intersection to the alternate road. The thick yellow lines represent congested roads. The thin and dotted blue line represent the alternate road. Let us determine the cost of the congestion by analyzing the entry points to the congested roads. It can be seen that there are many green arrows indicating the entry points. Big and small arrows represent big and small traffic inputs respectively. The small arrows represent traffic coming from the minor and side roads. If the alternate road is built, at least half the traffic in the congested roads will transfer to the alternate road. From major and minor roads, drivers will tend to use the new road because it is more efficient and better designed. They can arrive at their destinations earlier and at lesser cost. Note that the thick yellow lines have become thin and the thin blue line has become thick. This slide will show the increased coverage of traffic reduction by the 17 ground improvements. Traffic will not only improve in the immediate vicinity of the ground improvements enclosed in Box 1. Traffic will be improved even more on a wider scale enclosed in Box 2. All vehicles will want to travel from A to B. Beyond Box 1 are vehicles marked by green arrows wanting to go to their desired destinations. They can easily get through Box 1 because of the ground improvements. They will arrive at their destinations much faster, reducing the number of vehicles at the congested roads. This is especially important during peak hours. Such improvement cannot be achieved by the smaller influence area of the tri-level flyover. This slide will show how the alternate bypass road can be decongested in the future. A screenshot of Mandawi's master plan that is posted on YouTube is shown here. This alternate bypass road is almost exactly the same as that of Mandawi's proposed bypass road. In the 2015 JICA roadmap study, a coastal road is proposed. This road and a third bridge are plotted on this map. When the alternate road becomes congested 5 years after its completion, radial roads can be constructed towards the coastal road. When the coastal road becomes congested 5 years after its completion, it can be decongested by the JICA proposed LRT from Karkar to Danao. Or a BRT line can be built in the middle of the wide coastal road. We can really avoid future traffic if only we plan ahead. This slide will show the drawing details at intersection 9, the location also of the tri-level flyover. There is no more need for restrictive signs. At the intersection, a vehicle can go in any direction quickly. This slide will show the details of flared intersection number 1. Intersection 2, 3, 4, and 5. Intersections 6, 7, and 8. This slide will show the row requirements of both the tri-level flyover and the flared intersection. Zoom view of the core of the intersection. The row outer limits required for the flyover are marked in orange, while the row outer limits required for the flared intersection are marked in yellow. The flyover row is only slightly wider. An option would be to build a slightly wider flared intersection now for future use. Within a span of 10 years, buildings will be built in the vicinity. Traffic will gradually increase to become very heavy. With wide roads and intersections, flyover, underpass, BRT, or LRT can be easily built without the need to acquire row. The following video clip is a fly-through simulation of the alternate bypass road and 9 flared intersections. The simulation will go through the red line shown in the inset map. Intersection 1, 2, 3, 4, 5, 6, 9, 7, 8. This slide is a questionnaire to solicit information from the viewers of this video. To respond, pause this video and read the instructions at the bottom of this page. These are the people that contributed to the contents of this video.